Welcome back to the channel, guys. Today we are going to discuss the solutions to the problems that I gave you in the previous video. So first one was the Armstrong number. Okay, you take a 3-digit positive integer as input from the user and check whether the number is an Armstrong number or not. Like we are having 153. So 153 is an Armstrong number. Why? Because if I cube every digit of 153 and I add them, then I get 153 back again, right? So now how you will run the loop here? Okay, first I'm done using for loop and then I've also done using while loop. Okay, so what logic I have used here? Suppose we are having 153 only. Okay, so first what I've done is I have made this number an iterable, like a list. Okay, I have made this number a list. So x was equal to 153 in the form of a list. Okay, now I have made it an iterable because I have to use the for loop. Now I will iterate over this x. Okay, for I in x and y equal to 0. I have also created a variable y equal to 0. And now I start my iteration on x. So first of all, I will be equal to 1. Okay, I starts to iterate over x. Now, what I have done is, I am writing in this first iteration y equal to y plus int I cube. So why I have written int I? Because this input was originally in the form of a string. So this 1, 5 and 3 would also be strings. So first you convert that into an integer and then you write the cube of I. Okay. So in this first iteration, y is equal to 0. So 0 plus 1 cubed, that is equal to 1. So y equal to 1. Okay. So this is the I equal to 1 iteration. Now I equal to 2. Now in I equal to 2, again the same process is going to happen. Y will be equal to y plus I cube. Okay. Now y is having the value 1. Okay. From the previous iteration, and now I is equal to what? 5. So 5 cubed, now that is equal to 1 plus 125, that's equal to 126, right? Okay, now when I equal to 3, what happens? The same thing back again, y equal to y plus I cube. Okay, so y from the previous iteration was equal to 126, okay? So 126 plus the cube of I, and now I equal to 3. So 3 cube and 126 plus 27, that is equal to 153. Now y equal to 153. Okay, and then I am printing y, right? So I hope you would have understood this process of a loop, right? So try to do this in your copy also. Okay, if you are not able to do this program, you may have done it in some other way. Okay, there could be many solutions to the same problem. I have done it in this way, right? Next time I may do it in another way. Now let me just run the program. So I enter here 153 and it's giving me 153 again. Okay, so it's an Armstrong number. You can also give an if condition which can check whether y is equal to the original number. If it is equal to the original number, then you can print a beautiful message that it's an Armstrong number. Now that's your job, right? Okay, now we come to the while one. This one is a bit complicated, okay? So first we are taking num, which takes the number in the form of an integer. Okay, I'm taking 153 only. Okay, so num equal to 153. Original number equal to num, that is equal to 153, and then sum equal to 0. Now while num greater than 0. Okay, this is my loop, right? Num is 153. Now you're doing digit equal to num modulo 10. What will happen when you do this? Okay, let's just write this 153 modulo 10. Okay, what comes in the output? The remainder, that is 3. When you divide 153 by 10, not divide, modulo, then you get 3. That is the digit. Okay, you are getting 3. Okay, so digit becomes 3. Now we are doing sum plus equal to digit, cube of digit. Okay, so we do here the cube of this digit, that is equal to 27. So sum equal to 27, and now what we are doing is we are doing the floor division of num by 10. Then what will happen if I do floor division? 153 floor division 10. So you can see I'm getting here 15. Okay, so this 3 is getting removed. Why it will happen? You know that, guys, because it will remove the decimal part. Okay, if I would have done 153 by 10, then I would have got 15.3. And floor division will remove the number after the point. Right? Okay. So we have now made number equal to 15. Okay, now what happens in the next iteration? Again, it will try to do 15. Now it will be 15 modulus 10. 15 modulus 10. Now, what is that? 15 modulus 10? Fifteen modulus 10 is 5. So you're getting the next digit 5. So digit becomes 5 now. Okay, and now it will be cube of 5, that will be 27, plus the cube of 5, that is 125, because if you see I have written here sum plus equal to digit cube, and the previous value of sum was 27. Then you are doing the floor division of num again. Now num was having 15, and when you floor divide 15 by 10, you will get, what you will get? You get 1. Right, so num will become now 1. And 1 is greater than 0, condition satisfied. So now it will do 1 modulus 10. That will be equal to 1 only. Okay, you can check it. That will be equal to 1. 1 modulus 10. That is 1. And then you're doing sum plus equal to digit cube. Now the digit is 1. So now that will be 27 plus 125 plus 1. And that is equal to 153. And now you're doing num floor division 10. You can see what will come. Guess it. There's no guess. You know it. It's going to be 0 only. Okay. And now we are giving an if condition. If sum equal to the original number, then it's an Armstrong number. If not, then it's not an Armstrong number. Okay. I hope you understood this. Okay. Now let me just run the program. I write here 153. So 153 is an Armstrong number. I write here 407. 407 is an Armstrong number. Right? Okay. So this is done. Now we are having the factorial program. This is also going to be very super simple. Okay. Take a positive integer as input from the user. Find the factorial of that number. Factorial is 4 equal to 1 into 2 into 3 into 4. Okay. Now first we take num as 4. Now I am creating a variable factorial equal to 1 and I equal to 1. Okay. What's the logic? While I less than equal to num. Okay. Till that condition this is going to run. Then factorial equal to factorial into I. Okay. So I'm denoting factorial by F. Okay. So first I will be equal to 1. It is written here. So factorial will be equal to F into I. And F is equal to at the moment 1 and I is also equal to 1. So F equal to 1. No problem. Now I becomes what? I plus equal to 1. That is I becomes 2. Okay. Now what will happen in the next iteration? In the next iteration when I equal to 2. Factorial will be equal to factorial into I. So F becomes 1 into 2. That is equal to 2. Okay. Then again I plus equal to 1. So I becomes 3. So basically what is happening here, first you are getting 1 into 2 into 3 into 4. Successively we are increasing the value of I and we are multiplying it with factorial, which is storing the previous product also. Like first factorial was also equal to 1 and I was also equal to 1. Then we multiplied them and we got 1, which was factorial. Then we multiplied f into I was 2, and then we again stored it into f. Then we multiplied f with 3 and then again stored it into f. Then we multiplied f by 4 and then we stored it into f. Now when I was equal to 4, then in the last iteration, I plus equal to 1 will make I equal to 5. And when I becomes 5, this loop will stop because I will become will become greater than now. Okay, then this loop will stop and then it will print the factorial of the number, right? Let me just check it. See, 5, okay, you are doing 4, that will be 24. Simple. If I do with 5, that will be 120. Okay. Now try it out with the for loop. It is very simple. Okay. That's all for this video, guys. In the next video, we'll be looking at transfer statements. Till then, like, share, subscribe, and hit the bell icon.